welcome back to Math Mini Lessons. Today we're finding zeros of a function. We're going to do it two ways. We're going to find the zeros graphically, pretty much just looking at a graph and finding those x-intercepts where x touches, where our parabola will touch the x-axis, or finding it algebraically using quadratic equations, factors, completing the square, all those different methods from our previous units. So let's jump in. I'm going to have both here so you can get some practice with both, but looking at it graphically, I can identify that there are two zeros here. It's happening both at this point and at this point. So that's one way. And if it's a nice easy number where I can just clearly see the points, awesome. Sometimes that's not going to work in some of our graphs, so we want to also make sure we know how to do this algebraically. So all I'm going to do is take in our equation x squared minus x minus 2 is equal to 0, and we're going to factor it. And so if you don't remember how to do this, you do have to go back to that unit where you would get x minus 2 and x plus 1 equals 0. Again, all I'm doing is taking the factors of negative 2, and the only way negative 2 times 1 gives me negative 2, and negative 2 plus 1 will give me a negative 1, which is our b value. All right, so now that I have that, I'm just setting them to 0. And I get x is equal to 2 on this side, and x is equal to negative 1 on the other. So that means it touches at, oops, let me rewrite that, 2, 0, and negative 1, 0. And that's what we see. There it is. There's our 2, 0, and here's our negative 1, 0 on our graph. Okay, so that's the first way we can do it algebraically, and this is what it looks like when we have two zeros. But that's not the only thing that could happen. What if it only touches one time, like on this graph? And I do have the vertex there, and you can see that it's literally right there at that point, negative 1, 0. So let's prove that algebraically as well. I have negative 2x squared plus 4x minus 2. I'm going to factor out that negative 2 to have x squared minus 2x plus 1. Keep that out there. And now we end up having x minus 1 and x minus 1. Again, that's the only factor of 1 that can get to a negative 2 is negative 1 times negative 1 stays to a positive 1, and negative 1 plus negative 1 gives us negative 2. So let's work this out now. So here, negative 2 is equal to 0. That is not true, so we're just dismissing that. It's not an option. The second two are going to be the same thing. X minus 1 is equal to 0, so x is equal to 1, which makes our coordinate, it touches at 1, 0. And that's what we actually have. Okay, and that makes a lot of sense because I can see here this is going to be the exact same work. So I'm getting the same answer. Matter of fact, I'm going to just put that in there so we have it. Hit pause and jot this down into our work, to our notes. And now let's look at, well, what if it doesn't touch at all? And that could happen, right? Our parabola could be above or below the line and never touch. So I have no zeros at all. So what does that look like algebraically? So here I have 1/4 x squared plus 1 is equal to 0. Let's move that over. 1/4 x squared is equal to negative 1. I'm going to multiply both sides by 4. And I'm doing that so that this will cancel out on this end, and I'm just left with x squared is equal to negative 4. Now I have to find the square root. So x is equal to, and this is where it gets funky, right? The square root of negative 4? That's not real. Because square roots can't be negative. Because if I multiply two roots that are negative, I'm gonna get a positive number. So this makes no sense. Not a real solution. So this means there are no zeros. And what I mean by that is really just try this out. Can two numbers, when you multiply them together, make a negative number if I square them? There's no way that can happen. If I take two positives, I'm going to end up with a positive. If I take two negatives, I'm going to end up with a positive number. And I can't change that when I'm squaring a number. So I just want you to keep that in mind. There's no way that can happen. One has to be positive and one has to be negative. And that's why I can't square it and have this be real. So no real solution. This is what it looks like. And if that happens in your work where you have the square root of a negative number, it means there is no solution. Hit pause, jot this down. Okay, you have two problems to work on now. Here's our first one. So we're going to figure out what the zeros are in both of these. I've given you the graph, and now you're going to find zeros algebraically. So hit pause and solve these two on your own. All right, that was your spoiler warning. We're going to start with the first one. How many zeros do we see? Clearly, we see one. Clearly, there's only 1 0. But we're going to have to prove that algebraically why that happens. So you should have done this part and gotten x minus 3 equals 0. And x minus 3 gives us x is equal to 0. And because this is the same and this is the same, then we know there is only one solution, and that is at 3, 0. That's the only time it touches our axis. So check your work, see if you got that same solution. If you didn't, now's the time to hit pause and try to identify where there was an error in your work and make the correction. If not, let's move to the second one. So again, spoiler warning, we're gonna figure this one out. This one obviously has no zeros, clearly. Let's look at our algebra for why that is true. Okay, spoiler warning, done. We have negative 4x squared minus 2 is equal to 0. So you're just doing your algebra work. I'm going to divide by negative 4 here. And now I have x squared is equal to negative 2/4. You probably simplified this to 1/2. But you still have the same problem, right? Because now that you're going to find the square root, you're also, again, finding the square root of a negative number. So x cannot be the square root of negative 1/2. This is not real. No way would that be the square root of a number. So that's it. When you recognize that, that's how you can prove it in your work that there are no zeros in there. And that's it for today's lesson, Math Marbles. Now you know as you're factoring, and you can use all the different methods that we've learned for factoring, you can identify the zeros in your equation and use that to identify how many zeros you have on the graph and actually find those coordinate points, because y will equal 0. That's it for today. I'll see you in the next one. Be well.